Hi, this video will be talking about isotopes, mass number, and atomic mass of atoms. So first is isotopes, which is syllabus number 7. Isotopes are a form of an atom with the same number of protons, but a different number of neutrons in the nucleus. For example, hydrogen has many isotopes. Hydrogen 1, hydrogen 2, and hydrogen 3 are 3 examples. Hydrogen 1 has 1 proton, 0 neutrons, and 1 electron. Hydrogen 2 has 1 proton, 1 neutron, and 1 electron. Finally, hydrogen 3 has 1 proton, 2 neutrons, and 1 electron. The number of protons and electrons stays the same in each isotope, but the number of neutrons changes. Now, the way that isotopes are named is pretty simple. As you can see in hydrogen 1, the isotope name starts with the name or symbol of the element, then a hyphen, and then the mass number. Since we haven't gone over how to calculate the mass number, let's take a look at that now. Mass number is a part of syllabus number 8. The mass number is the mass of an atom as calculated by adding the total number of protons and the total number of neutrons together. So, let's take another look at hydrogen 1 and how we name isotopes. As said before, hydrogen 1 has 1 proton and 0 neutrons. 1 plus 0 equals 1, so the mass number, or the number immediately following the hyphen after hydrogen, is 1. Now, you try to write out an isotope of lithium. If an isotope of lithium has 4 neutrons, what is its mass number? And how is that isotope written out? I will give you a little bit of time, but feel free to pause the video to work it out. Okay, so if we take a look at the periodic table, we see that lithium has an atomic number of 3, meaning that it has 3 protons. As stated in the example, this particular isotope of lithium has 4 neutrons. Since the mass number is the number of protons plus the number of neutrons, the mass number of this isotope is 7, and this would be written out as lithium 7. Okay, now let's look at another way that we can apply mass number. The notation for chemical symbols looks like this here. Atoms are often written out like this to quickly show the atomic number, mass number, and charge. As a refresher, atomic number is the number of protons, mass number is protons plus neutrons, and the charge is the difference between the number of protons and the number of electrons. So let's try to make one of these. If oxygen has 6 electrons and 7 neutrons, how would you write out its chemical symbol? Pause the video and take a minute or so to work it out. Okay, this is on the right is what it should look like. If you look on the periodic table and find oxygen, you'll see that it has an atomic number of 8, as you can see in the picture on the left here. This is the number of protons, and that goes to the bottom left of the chemical symbol O. Next, for the mass number, since oxygen has 7 neutrons in this example, the mass number will be 8 plus 7, which is 15. And that goes on the top left of the chemical symbol. Finally, for the charge. Charge is found by subtracting the number of electrons from the number of protons. 8 minus 6 is 2, so the charge is 2. The sign on the charge is negative because the atom has to gain electrons to complete a valence shell, which seems backwards the way you write it, but I always just remember it as the opposite of what I think that it should be. Now for syllabus number 9, atomic mass. The atomic mass of an element is the average mass of all naturally occurring isotopes of an element. The atomic mass is found on the periodic table directly under the name of the element as circled in the picture. To calculate atomic mass, you have to know two things: the masses of each isotope of the element and the percent abundance of each of these isotopes. For the equation, you multiply the mass number of one isotope by its percent abundance. Then, you add that number to the product of the second isotope's mass and percent abundance. Continue this pattern with all of the isotopes of one element. Then, divide that number by 100. This will give you the atomic mass in AMUs, or atomic mass units. So now you can try. If gallium has two isotopes, Gallium-69 has a mass of around 68.9 atomic mass units and a percent abundance of about 60.1%. Gallium-71 has a mass of around 70.9 and a percent abundance of about 39.9. So what is gallium's atomic mass? Okay, here on the slide is a picture of how to work out the problem. Start by multiplying 68.9 times 60.1. Then multiply 70.9 times 39.9. Then I don't have those values written here, but add those two numbers together and you should get a sum of 6,970. Finally, divide that value by 100 to find the atomic mass, which should be 69.7, meaning that gallium has an atomic mass of around 69.7 atomic mass units. And that is all for the syllabi 7 through 9, so thanks for watching and I hope this was useful.